Alright, amigos, we are looking at the video for quiz. Oh, if my pen's gonna work. I'll watch this, it'll just backload on it. There you go, a bunch of times. Alright, quiz number 5. This quiz is the first half of chapter 7. So we're looking at chapter 7-1, -2, -3, -4, and -5. So if you want to look at that in your textbook, that's in the 300 somewhere, about 350 on. Okay, or maybe 320 on. That's what I meant. 320 on. Anyway, so let's go over some of the things that you're going to see on your quiz, and we will get you on your way. Okay, first thing, you're going to see sets of parallel lines, and I'll try and make these as parallel as possible, and with a transverse. Okay, and a transversal is just a line that comes across two parallel lines there. Now, what we need to know about this is my spots with red dots are the same. Okay, and the rules behind that is vertical angles are the same. So these would be vertical angles right here. These would be vertical angles. And we also have a rule that says opposite interior angles. So interior angles are on the inside of this. So opposite interior angles are the same thing. And opposite exterior angles are the same thing. So you can see that all the rules seem to match up on that. So all our red points there are the same. And conversely, all our green points are the same when we come to measuring degrees. And this is the same thing as vertical angle, opposite interior, and opposite exterior. Just like that. Okay, so if I were to give you one of these angles, you could use that information in order to find all the other ones. So if I call this angle right here 120 degrees, you know that this one is 120, this one's 120, and this one's 120. Now, the question is, how do I find the other ones? Well, what I know is this. If I'm looking along this line right here, from here to here is half a circle. A circle we know is 360 degrees. So half a circle, it would stand to reason, is 180 degrees. Well, if I already know that this part of my angle right here is 120, I can find out the other part of the angle right here just by doing some subtraction. So I take 180 minus 120 and leaves me with 60 degrees. So I know this is 60 degrees, and because that one's 60, this one's 60, this one's 60, and this one's 60, and then you'll be able to fill them all in. So you've got a question like that on your quiz. Now, the next thing that we're going to cover is parallel and perpendicular lines. So when we have two lines that are parallel, and let's say that they're labeled W and X, I could say that W is parallel, that's the sign for parallel, to X. And what if it wasn't quite like that? They didn't have the names of the lines, but they just had points on there. So let's call this A, B, C, and D. Okay, we know that we can write what a line looks like by using these 2 points. So we'll say line AB, and we'll put a line on top with the little arrows, saying that's the whole line, not a segment or array. And we know that line CD can be written like this. And then to do parallel, we just use that same notation we used before, and that's it. So that's another way we can do that. Now, we discussed that sometimes we're going to run into perpendicular lines. Perpendicular lines cross at a 90-degree angle. So when we look at it right here, this should be 90 degrees all the way around. Okay? So I could say that, let's call this line W, and this, I think we called this one line W last time. Let's call this one line Y. Okay, we could say that line W is perpendicular, and when we say perpendicular, we do an upside down capital T to Y, just like that. Or if we were using the point system, we'd do the same exact thing we did before, where we've got a couple of points. Let's call this E and F. I could say line EF is perpendicular to line AB, and both those notations would be just fine. Alright, next thing, we talked about triangles, and if we have a triangle that we know a couple of the pieces to, so let's say that this is 90 and this is 40, we know that the interior of a triangle, all the angles added together are 180. So if we know two of the angles and we don't know what one of them is, we can just subtract from 180 our 40, and we'd get 140. And we could subtract 90, and we'd get 50. The 50 degrees that we have left is what goes right there in that corner. So pretty simple. That's not too bad, as long as you remember that inside a triangle is 180 degrees. But we did run into a problem where we had a triangle and we had two that were missing. Okay, so something like this, and we knew that this was, let's say, 30 degrees, but we didn't know this one or this one. And what they told us was that it was a special triangle. We have a couple of different kinds of triangles. We've got equilateral, we've got isosceles, and we've got scalene. And what we know about isosceles triangles is that these two sides are the same and these two angles are the same. So this is, just by the way it's drawn, an isosceles triangle. So I know that these two are going to be the same. So I just need to take the 180 that we talked about before, which is the total number of degrees inside. We're going to subtract the 30 off, which gives me 150 degrees left. And I just need to split that between the two angles there. So I just divide that by 2, and that'll give me 75 degrees for each one. And that's what x equals. Alright, the last thing was talking about classifying quadrilaterals. You remember that quadrilaterals all have 4 sides. Okay, so this one's got 4 sides. Okay. Then there are special quadrilaterals with 2 lines that are parallel. Okay. But the other 2 are not. So, and these are called trapezoids. Okay. So everything on my screen here is going to be a quadrilateral. And we've got trapezoids. So the trapezoids are quadrilaterals and trapezoids. And then we've got another classification called parallelograms. And that means they have 2 sets of parallel lines. So the top and the bottom are parallel and the sides are parallel. And then we've got special parallelograms where the corners are 90-degree angles, and we call those rectangles. We also have other parallelograms where the corners aren't 90 degrees, but all the sides are the same length. So this is the same as this, the same as this, same as this, and these are called a rhombus. And the spot where all 3 of these intersect in my Venn diagram here is our square. In a square, all the sides are the same length, and we have the 90-degree angles. So if we were to classify a square, it would be a square, a rectangle, a rhombus, a parallelogram, and a quadrilateral, but not a trapezoid, because a trapezoid has 2 sides that are not parallel. A square does not have 2 sides that are not parallel. Okay, that's it. Quiz tomorrow. Have a good one.